Okay, so I've now produced my IMR, my 3D plan, should I say, and I'm now going to have a go at an IMRT plan. And the technique we're going to use is rapid arc to plan our patient. So we've got our plans here. We're going to keep those because we can use those later. And we're going to do insert a new plan. And I'm going to go next, 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 same as before. Kick in next. But we've got a few things we need to do a little bit different here. So I'm going to call this RA MC, so Rapid Arc MC. This time we'll put the dose in where we should at the beginning, so 37 fractions at 2.054. Then we're going to click OK. We're using shoe variant 1. OK. Now this time we need to set the beam up as a rapid arc beam. So we're going to up here on the tabs, we're going to go geometry, and the technique we're going to use is an arc technique. So change that to there. Now this is the bit where I'm going to allow you to have a play with this and decide what you want to do. There's a number of different arcs, and you'll probably do a variety of things in your department. I'm just going to have a really simple half arc going from, what am I going to do? I'll do from 90 degrees to 270. Now that's not necessarily optimal, so you have a think about how you decide where your arc might want to go. Okay, so we've got our field on, and then we're going to add some MLCs like we did before. So we're going to right click and we're going to do new MLC, and we can see here that we're going to keep that as is, but this time we're not going to do anything in terms of setting the leaves. We're going to leave the planning system to do that for us. So with our fields on, and then the next thing we need to do is optimize the position of our field, and there's a tool that does that, which is called the arc geometry tool. So we go into planning and we click arc geometry tool, and we're going to click fine tune and fit collimators to target, and what that does is it optimizes the position of the arc in order to treat the patient. And then we're going to close. So that's pretty much our patient set up, and we're ready to enter the optimizer. So if we go to planning now, again at the top, and VMAT optimization, we're going to click close on there, and this is our optimizer. So we can see here we've got on the left hand side we've got our structures and the dose that we want to, this is where we're going to tell the planning system what our priorities are. Okay, so we're going to start off nice and simple and work it up. So the first thing I'm going to do is just tick that normal tissue sparing objective. So we're telling the planning system we want to minimize dose to normal tissues as much as possible. And then we're going to have a think about the doses to our structure. So the first thing I'm going to think about is how much dose I want to give to my PTV. Okay, so I'm going to set an objective for the maximum dose I want to give it and the minimum dose that I want to give it. Okay, so so the planning system automatically defaults to this number here. Okay, now if we look at our tolerances here, we can see we want from 72.2 to 79.8. So what we could do is have a look at tweaking that a little bit. So as you're going to see when we work through on this, that this is a little bit of suck it and see. So what I'm going to do for the purposes of the demonstration is just leave that set as it is, and we might change that later on. The next thing I'm going to add in is my rectum constraints. So we can see here that we've got 1, 2, 3, 4, 5 different constraints that we'd like to meet for our rectum. So we can tell the planning system that that's what we want to do. So what we're going to do is click on our rectum icon there, and I'm going to add upper objective, and I'm going to go 1, 2, 3, 4, 5. So, and now we can type in what our objectives are. So we can say, if we look at our protocol, that we want no more than 70% of the rectum to receive 40 grey. We want no more than 60% of the rectum to receive 50 grey. More than 50% of the rectum to receive 60 grey, 15% 70 grey, and 3% 74 grey. So I've just typed all of those in, and you can see that it's put some dots on here. Okay, so what we're saying we want to happen is for the PTV line, we would like it to go along here and then drop really steeply below there. And for our rectum line, what we would like it to do is to stay below those dots and do something like that. So that's what we've set the planning system to do. We've got obviously more tolerances in our protocol than this, but we're just going to keep it simple to start off with, and then we're going to let the optimizer do its bit. So we're going to click go. So just while it's starting to tick over, I'm going to untick all the lines that we're not interested in at the moment. So we're only interested in the rectum and the PTV. Okay, so I'm just going to pause this for 1 second so that I can tell you a little bit about what else we need to think about. So at the moment we've said that we want to achieve all of these, and all of these are of equal priority. So if we remember, the priorities are all relative. So that is 50 and that is 50. If that said 100 and that said 100, they'd be the same. If we change that to 100, that'll be twice as important as that. Okay, so let's just click it going again, and we can see here these lines tell us how easily it is in terms of meeting the requirements we've asked it. We can change that to a bar chart if we wanted, or keep it as a line. So that tells me that it's easily meeting the rectum because it's really low down, and it's struggling to meet the PTV tolerances at the moment. And we can see here that it goes through 4 different processes to optimize the plan. So what we can do is a couple of things really in terms of seeing that that's not going to meet that. So straight away I can see that's not going to do that. So what I'm going to do is change this, and I'm going to change it quite extremely just to make a point. So I'm going to say you're not meeting this point here. So what I'm going to tell it to do is make this point here, so if I click on it we can see this little thing turns red there. That's the most important thing that I want you to achieve, is minimum dose to PTV. So if I change this to 100, I'm now saying that that's the most important thing above anything else. And so can you see straight away that line starts to move across here, but at the expense of this here. So it's no longer meeting this point here and this point here. And if I was to change this even higher, I don't know, let's say 120, then probably what it's going to do is meet that. There we go. So you can see it's moving across there, but now it's not meeting our rectum tolerances, which is a bit of a problem now. So we need to have a bit of a rethink about what we're asking it to do, because essentially this is telling us now that we're asking it to do something that it's not able to do. So it's just coming to its final calculation for this run, so I'm just going to let it calculate and we'll have a look at the dose distribution. Okay, so I just paused it there when it was doing its final calculation, and now it's actually calculating the dose distribution. So the first section is where it calculates the fluence, and we'll talk about that in class, and the second part is where it calculates the sequences for the beams. So if we've not talked about this in class at this point, then give me a shout and I'll explain the differences between the two. So we've got our first distribution there, and the first thing we need to do with our distribution is normalize the plan. And if you remember, we've normalized the plan to the mean dose distribution. Okay, so we can see here that we've got quite an unusual dose distribution going on. Can we see how we've got all this dose up here? Okay, and the reason for that is because of the arc that I've chosen. So I've chosen a a half arc, so there's no dose coming posteriorly, so it's really going to struggle to meet that. So what I could do is change my arc if I decided at this point that that's not going to happen, and that might have been a sensible thing to do if that was the real world. And the other thing that we can see is our beam sequence if we want. Let's just turn off these isodoses, these 3D isodoses. And what I can do if I click play now, you see that? It plays the sequence of the beams. So I'll leave that video there and we'll come back to this in a moment.